In this example, we're going to build the basic Phaser starting game and go through that. So I have my project folder open. I'm going to add my index file to it. And with this, I will use VS Code to help out. So now we have a good start there. One thing I am going to do, just for reference, I am going to add an additional folder to this workspace. This allows me to open our previous project that we worked on so I can look at that. And what I really want to do is I want to grab the script because I don't have that memorized and I'm not going to be working with a downloaded version of the Phaser JavaScript game library. So with that, we're going to work on creating our core starting game. As soon as we put this in here, we can hit save. So now that's been saved. Now this time, instead of writing everything into this same document, what we can do is we will put it into a separate JavaScript file. This helps us keep a little bit more organized as we work. So that means I need to add a new file here. So I've now added in that file and we're in pretty good shape. Once again, we start out with the config for it. This is where we set up our game. And so type will be Phaser Auto, width will be 800, height will be 600, and then our scene that we will be referencing. Now, the thing to work on with this is notice we're creating these scenes, and as we build more complex games, we will have additional scenes in those games. But there are the three primary functions that are part of Phaser: preload, create, and then finally update. So we work with these three functions as part of our project. Now I'm going to create my game object, and it'll be a new Phaser game. Remember that this version of the word game is capitalized. And then I need to pass into it my config options. Now, it's possible that we could just put all of that information directly in here, but it's much easier to pass in the config object and keep it separate. It helps to organize the code as we work. So now I will have my function preload, my function create, and finally my function update. So that gives us the three functions for the project and gets it updated and ready to go. So we can save this. So it creates a new Phaser game. It has those config options with it. And the next step that I want to do is to pull up the live server. So we have the command palette, Command-Shift-P, and then we will choose Open with Live Server, and I want to open Game 1. Game 1 has opened. I've pulled up the console so we can see if there's any error messages or other things that are going to be happening as part of it, but we can see we have our core Phaser game. Phaser's loaded. We don't have any active error messages affecting us right now. I have added an assets folder to my project with some starting assets. These are the default assets that can be obtained from the Phaser website or downloaded as part of this starting project. Now, with those assets there, we're going to load them. So in this example, we are using local assets. In the previous example, we used assets that were downloaded from a server. And both are acceptable ways to work. To verify everything is working, I am going to first just work with the sky and make sure that the sky is loading. And now we can, this add.image, not this image.add, so this add.image. And we load it. Now this sky image is the size of the game, and image assets have an origin point set to their center. So this is why it's putting in at the center of our game, which is 800 by 600. So the center would be 400 by 300. That should add the image to the project, and we can now see that the image has indeed loaded. So we have the background image as part of the project. Now we're going to add a few more assets that we will use for the game. So we have a ground that we will add. So everything in that folder is going to be loaded, and they will all be the same except for one. And the one that will be different is going to be the dude PNG, because that is going to be the player, and it is a sprite sheet. It is not a single image file. So that one does use slightly different code, so we will load all of these that are the same first. And if copy pasting works well for you, you are welcome to use it while you are putting it in, so you don't have as many typos as I am making currently. So instead of loading an image, we will load a sprite sheet. It is not camel cased, it's all lowercase. It will have an identifier or key of the word dude. The file we're loading is assets dude.png, and this time when we do it, we also need to tell it and how wide it is, and we use frame width that is camel cased, has 32 pixels wide, and it has a frame height of 48, sorry, not 32, it's 48. It's rectangular, not square. So when we look at that now, we can see bomb is a tiny little graphic, platform is a green bar, we've seen the sky, there's the star, we go to dude, and we see that it's a sprite sheet. Each frame is 32 by 48 pixels in size, so you can see where we have 4 frames walking left, a center frame staring forward, and 4 frames walking right. So we will build animations into the project that go along with that in a few moments here. But first we have to add that. Now, something else about adding in assets, if I were to say this.add.image, and we'll just put it at the same 400, 300. But this time if we added in the star, and if I save this, when I look, oh, well, we do have to type it correctly, and image is not a word, so we'll switch that to image. The copy pasting probably would have helped me there. And now I can't see that star because it is behind it. But now if I put the star on top of the sky and save it, we can see the stars there. So load order matters. The sequence that we put it will matter as we add it in. And like everything else, as we're setting the origin of this to the center, because that's how images load, there's a set origin method where we can change the origin of the graphic. We could say put it at top left corner 0, 0, and then we would draw the sky at 0, 0. But we don't need to do that right now. But that's just something we could do down the road. So we're off to a good start. What we want to do now that we've loaded assets, we're going to add in the platforms since we're working on creating a platform style project. Now as we add the platforms, and remember we leave sky at the back, so we load sky first. Then we will say platform. So we need to make a reference to the platforms as we're going to put them in, because we will have to refer to them in multiple locations. The sky, when we load it, is just a static decorative image, so we just load the image and we're done with it. But because we need to reference the platforms as we add them later, we need to be able to know what they are. So we'll create a static group, and when we're doing this and adding in these platforms, we're tying them to physics, but we haven't added physics to our config yet. So what I'm going to do before I continue more there is I'm going to go up and add in my physics into the project. And the physics, as we add it, we use default, and the type of physics we will add will be arcade. And then we define the arcade physics we're putting in. And unlike the previous video where I misspelled arcade, this time I believe I have it spelled correctly both times. And then we'll put in gravity, and we're only going to be having our gravity pull in a y direction. So a higher number will make objects seem to weigh more. So just something to keep in mind as you are working. So we can see how, and I need that final comma there. It's really easy because I added the curly brace after physics to forget to put a comma, because this is a value or a key and a value option. Key value, key, here's the value, comma, key value, the last one, of course no comma after that. So actually I'm going to set debug to true. It will be apparent what it's doing once we start adding more assets into our project. Now back to here where we are adding the platforms to the physics. So what we're doing is we're saying they're now going to have physics properties, but they're part of a static group. And what that means is it's something that can now collide with something else. By putting it into a physics, adding it to physics, that means it can now engage in collisions. But static groups do not move when they get hit, and which means they're really good for unbreakable walls and other barriers or boundaries within your scene. But they also then are not affected by gravity. The alternative to static, of course, is dynamic, and some of our physics objects we'll be working with will then be dynamic. So now with our platforms, we're going to create, and we will create a platform and this is going to be the ground, the actual bottom of our scene, and we will set that into it. So now when I go, I see there's the ground, but it doesn't fill the ground all the way. So we could have a separate bottom ground and have a different artwork for the platforms, but because we're using the same one, we can very easily change its size. We will scale it, and when we do that, we will see it scales up. Now there's a blue box that's appearing here, and this blue box is a representative of the physics body of the object. So when we changed the scale of the object, we did not update its physics body. So we need to then call the refresh body method on it. Now when I look at it, the blue box goes all the way around that platform. Now to create the other platforms for the player to land on, we'll just put some platforms in, and this will give us platforms that are spaced decently so that the player is able to move around on the screen. So I'm changing this one to 5250 and this to 750 and 220. And this is all based on creating a set of platforms so that the player has something to jump on. The blue line is the physics body of the object. And the reason we can see that is we set debug equal to true. If I set debug equal to false, we never would have known that the physics body did not match the object until the player fell into the scene, and then it didn't interact with that platform except where that blue box is. So during development, I find it to be very useful to leave that physics body on. And as we add in the player and the other objects, you'll see just how helpful it really is as we work it into the scene. Now it's time to add in the player. So we'll create a variable reference to the player so that the player will exist in the project. And now inside of create, so player is equal to this dot physics dot add dot sprite, and we will put it at 100, 450, and tell it that we are using our key of dude. Remember, when we loaded the images, we set keys for each one. So we have dude, sky, ground, star, bomb. That's how we can then reference it later on in the code. So this is now, we add it to the physics engine of our game as we are working so that we can see it happening. So if I save this and reload, whoa, wait, what just happened there? Let's refresh the screen here, and he disappears. Or she, not quite sure. They, it's kind of a genderless, weird alien creature. So we've added it in to our scene. But now what we want to do is set a few other properties on it. We will set our bounds, cameled, and the bounce we will do is 0.2. And we'll play with that number a little bit to see how it all works out. And this time we'll also say set collide world bounds. So instead of having to do 4 checks to say, hey, has my player run into any of the 4 boundaries of the world, now when I do this, we can see the player goes and falls and drops on the scene. We have this red box showing that it's a dynamic body. We also saw a green line indicating the direction of its velocity. Now I'm going to change this bounce here, and let's say bounce of 0.9. So save that, refresh, and now we can see where it loses energy, and that green line indicates, of course, where is my velocity vector pointing and how strong it is based on the size of that green line, and eventually I come to a stop. Now if I set bounce equal to 1, we'll see that the player never, ever, ever stops bouncing. If we set it equal to 0 and the player hits, there is no bounce. So setting bounce is something where you have to experiment with it. You have to try and find out what's best and what's appropriate for your particular game. Continuing down our path of collisions, we're colliding with the world, but if we look back at the game, we can see how the player did not collide with a platform, being the ground as one of the platforms. So now what we can do is tell our physics to add a collider. Well, as I said, a collider, so I typed it. Physics add collider, and then we tell it who is going to collide. And I will say player and platforms. And when I do that, now if we run this, oh, we got a little typo on here. Oh, it's not player.add, my bad. This is something that the game's physics, because the physics don't belong to the player. Remember, every other time we said physics, we use this. This is in reference to the game object. So anytime we use the word this, we are referring to the context of the game itself. So the game owns the physics. We passed physics into it during the config. So game owns the physics. Game owns the objects. So then we can tell physics to add a collider. So now we can see it bounced and stayed on the ground. So it's on the platform. So that's something to remember. Anytime we use the word this, we're referring to the game itself. So the context of the game. And the game owns the physics. That's why we can add a static group of platforms. That's why we can add images. That's why we can add physics, because the game owns it. The game can load images. It's the power of the word this. I'm going to add some animations in now. Because we have a sprite sheet, it's time to take advantage of that with the player. So we will code what the animations are going to be, and then we need to add in the keyboard control called cursors so that we can work with that. So I've gone back in my code to player because this is where we really care about it. So these are about the player. I like to keep the collide separate and have this code near the player because this is tied to the player's animations. You will notice that I didn't say player's animations create because the animations themselves are tied to the scene, and the animation manager that's built into Phaser, but they are going to deal with the frames and artwork of the player object, so it makes sense to have them here. So we create this animation. The animation is going to be a key value pair object. So anytime we do that configuration in JavaScript, that type of object goes inside curly braces, and the key we will be using will be left to correspond to the left key on the keyboard. And then we will tell it what frames we're working with. So we'll say this. Let's try that again, ANIMS. And then we will generate frame numbers on the sprite sheet that has the identifier of dude. And we're going to tell it to start at 0 and end at 3. Now if we go back in dude, we'll look here and we'll see that would be 0, 1, 2, 3. This will be number 4, 5, 6, 7, and 8. So it's important to keep that in mind while we are doing this. Now I can put a comma after this. Frame rate will be 10 for this animation. And repeat will have a value of -1, which means do keep repeating it. We're going to have a nearly identical version for right. So I used copy paste for it because my fingers do seem to be a little bit sloppy or fat on the keyboard today. So this one is frames 5, 6, 7, 8 has a value of right. And then we have our standing forward frame, which we will give a value of turn. And this will be the frames we work with: square brace, curly brace, and then the key will be dude inside quotes. And then we will be using frame number 4 to achieve that. And then our frame rate will be set to 20 on it. So this is a single frame, so we don't need to generate the frame numbers. So then we just pass to what we are creating with this, what artwork and which frame we want. We could manually have worked out all the frames and written them all down, but we might as well take advantage of when it can automate a process. Now, 0, 1, 2, 3, that's 4 times. That's not a big deal. But if you have a much more complex animated sprite sheet, so it has lots and lots of frames, then you probably will want to use something like generate frame numbers. So this now generates the frame numbers that we need for our animations, and the next step will be to tie it to keyboard input. We don't have anything to see yet, which is why we haven't jumped back over to our game, but we will in a moment. So now we can say let cursor be our value there, and to populate that we can say cursors, and we're in create, is equal to this dot input keyboard create cursor keys. So that calls a method that means it will allow me to use the arrow keys on the keyboard to make it work. Now, I still haven't done anything yet because I haven't said what happens when I press those keys. And that's where we will finally be able to put something inside our update function. So we can say if cursors dot left dot is down. So if I'm pressing the left key, I'll tell the player our set velocity in the x direction to negative 160. Else, if cursors dot right dot is down, player dot set velocity x will be equal to positive 160. Else, and then curly brace, player dot set velocity x will be set to 0. So now we should have something to see, no error codes there. And I have to click into the area to make it active. That's part of web safety protocols. Now we'll notice we don't have any animations happening. It's on the very frame 0 of the animation, so we haven't it's not behaving quite right because we haven't said what frame do we want to see. It's moving, but we don't know what frame we're looking at. And this is where we can then say player.anims.play, and we will tell it to play the left animation. This is why we gave them key values, so we can refer to them by name, and we want that animation to loop. If we don't provide that true there, then when we try and run this, it doesn't automatically loop for us. It goes to whatever the previous loop option was whenever we had, oh, and I forgot a comma up here. See, one thing VS Code is great. It's telling me, hey, that is not proper JavaScript syntax because you're missing some punctuation. It doesn't care that it's like it doesn't know what phaser requirements are, but it knows that I should at least have a comma there to be correctly written JavaScript. Now let's try this one. Player anims.play, and this time, because this isn't a looping one, we can just say turn. Now if I save this, let's go here. Now we're facing forward, left, right. Hey, look at that. Now we can run, but we can't jump yet, so we need to add in another option here. So that is our left and right movement. But if I were to say if cursors dot up dot is down, and and we want to do this, we should only be able to jump when we are on the ground. So we'll say touching down. And this is, again, the nice part about using a physics engine. We don't have to create our own flag to say, hey, the player's touching a platform or ground object, so now we set our flag to true, then we can finally jump. We don't have to do that. It's baked into the engine, which is pretty awesome. And now we're going to set our velocity y this time instead of our velocity x, and we'll set it to negative 330, so that means we can overcome the forces of gravity. Save this, go here, hit the up arrow, and you can see the green bar indicating what is my vector of velocity, which is pretty cool. So our little guy can kind of run in there. So this is what we're going to use for this particular example because it allows us to be able to get to all the platforms. If we wanted to limit, so once we're moving in the air, we can't add any more changes to what we're doing. We have to adjust it a little bit so we don't automatically kill the horizontal vector the moment we let go of an arrow key. And so we could just say once we jump, we have whatever momentum we have, and we maintain that while gravity affects us until we're on the ground again. And once we're on the ground again, then we're able to provide further input. So there would be some ways you could do it, but you would have to move the platforms around to allow the player to have adequate ability to jump or move between them. So we're jumping around here, which unless you're at UW Badger football game where you do the jump around, it gets kind of tedious after a while. So we need to have some purpose. And for this, we're going to collect stars, score some points, and then we'll have bombs come in that will be game enders. You touch a bomb, you're done. So let's start with that. We'll add stars. So let's add in the stars. Up there under our global variables we're working with. So we have the game, and then we have our in-game elements that we're working with here. So to add in the stars, what we can do is say stars is going to be equal to this dot physics dot group add dot group, and this is just going to be a group we're going to add, and we're going to allow Phaser to help us here, and it's going to add multiple. Unlike the platforms where we manually added each one, this time because we'll have a repeating group of them, it will add them to the screen. So when we do the physics add, it automatically is going to be adding one, and then what we're going to do is be able, well, I already had key, then we'll repeat this 11 times, so we get a grand total of 12. And then we'll set the X and Y position of the star, and the X will be set to 12, Y will be set to 0, and we'll step on the X 70. So that means a new star will be placed. The first one's at 12, the next one will be at 82, and then we add 70 more, 70 more, 70 more until we've looped through this 11 times. So it's pretty cool. So now what we can do is say stars, whoop, not that. Code completion's funny sometime. Stars, children, iterate, and then we will be iterating over these different children within it. And we're going to give each one a random bounce. And the reason we're doing that is it's going to mean each star behaves a little bit different, so it's visually a little bit better. And then 0.4, 0.8. So the bounce is going to be between 0.4 and 0.8. So we're grabbing that value as part of it. So then that adds the stars in. So if we save this, jump over and we can see the star. Oh, whoops. Let's watch that again because it's kind of fun. You can see how the stars come down. We set their bounce, but what we haven't done is we haven't tied them to anything to allow it to collide with the world or anything else. So that's easy enough, because if we remember where we have now the player and the platforms are colliding, what we can also do is say this dot physics dot add dot collider, and this collider will be the stars and the platforms. So now when we save it, we'll see how the stars, and they're all bouncing a little bit differently from each other as they hit the platforms. So that works out a little bit better with it. What would be really nice is if we could then have the player so then we will have the player collide, but we're going to use a different method, and we'll use overlap because we don't want the player and the stars to bounce. Actually, we're going to do that just for fun first. Just for kicks. Now let's see what happens. So you can see how the player is able to, oh, but notice how the stars, they're not checking for the bounds of the world, so we can run them off of the screen. So we probably need to think about that, or if we were going to make the stars where we could push them or bounce them off the screen, but we're not going to do that. Instead, this time we're going to use overlap, because overlap allows us to have the player and the stars overlap, and then we're going to call a method when that happens. And then we just have two more options on this, null and this being the context of the game, and then null, we have to go back and read the documentation to get the full details on that. So for any of these, we can always go find the documentation and go into it in more detail. But for now, we only care that when these two objects overlap each other, when they're little boxes, they're physics boxes. So looking back here, that the red box around the player, the red box around the star, when those overlap each other, it's going to call collect star. So that means we need to write that function. So we'll call collect star, and when we call collect star, we are passing to it the star that overlapped with the player. So we have these two parameters. We pass in the player and the star, and then we'll tell the star to disable its body. So this now disables its physics body and effectively removes it from display. So when we now run this, oh wait, I forgot to turn off the collider with the player. Oh, here we go. So now when we hit a star, we can see how it disappears. Now the physics body's there, it's showing us where it was, but it's no longer interacting with the player. So we're able to then collect these different stars with our project. So looking at collect star, where it passes in player and star, if I look under my overlap method here where I'm passing in player and starts calling collect star null this. So we're going to see what those actually mean here. So if I look under overlap, I have the two objects. The order matters because in that callback, when they overlap that function, that callback, it expects the objects to be handled in that order. That's why we use those as our parameters with it. So now we have process callback and context callback. So the process callback would be an additional check that we could run, and if we want, we can do it in we use this because that's the context in which is calling it. So using the documentation can be a useful way to understand a little bit of what is happening inside our project. Now, going back into the code, when we disable the body, we disable the physics so it's no longer bouncing, and then we remove it from display. That's why we have our true and true happening there. So the next thing that I want to do is set a score value. We'll just give it a beginning score of 0, and then we can score text. This will be score text that we use to show the score on screen when we collect stars. So score text is going to be this .add.text, and we specify an X and Y location, 1616. We will then, comma, not period, so 16 comma 16 comma, and now my single quote score colon space 0 end quote comma, and now we put in some of our font information. So I'll say font size. This time I will give it a value of 32 pixels, and I will fill it with a color. I can fill it with whatever color I want. In this case, I'm going to fill it with black. So I use the hex of hashtag 000. So that now puts my score text on screen. I can save this and look at it, and we can see scores there. Now we're not collecting the score yet. That's something we still need to do, and that will happen under collect star. So after we disable the stars, then we can say score, if I spell it right, plus equals 10, and then score text. We'll set the text of that text string as it shows up on screen to our new value, score, plus the score itself. So now, when I do this, let's go try and get a score, and we can see how my score is going up every time I run into one of the stars. If this is going to go out with a bang. So with that, we need to add in the bombs. So we'll add in a reference to the bombs, then we'll go into our create function, and then we can say this dot physics dot add dot group, and this dot physics dot add dot collider, and this will be bombs and the platforms, and this dot physics dot add dot collider. We don't care about overlap, we just want when they hit, and it will be the player, the bombs, we'll call the hit bomb method, and then once again null this. So we're using a collider, which we could probably do the collider with the stars as well, but with this, because the game is ending, we just want it to touch and be done. So to add in when we hit a bomb, so So hit bomb, and that is going to take player and bomb as parameters. And when this happens, we'll tell our physics to pause. Player, we will set our tint, and we will set the player to where we're adding in our red color. And then tell the player to show its turn animation as part of it. So that takes care of hitting it. But what we don't have is we don't have any way for the bombs to show up on screen. So this is where we're going to make it so a bomb appears after you've cleared all of the previous stars. So every time we collect a star, we're going to check and see if our how many are active, and if the number of active stars is equal to 0, then what we want to do is reset the stars and launch a bomb. So to reset the stars, we will tell the children, all of the stars in that group, to iterate, and we'll iterate over each one, and with that we will tell the child to re-enable its body, and then leave its x as its x. We'll set its y back to 0, and you can go look up the documentation for gaining the remaining trues on there if you want. And then what we can do is create a variable. We'll call it x, and we'll set that equal to the players dot x. Well, wait, we're not setting equal to. We're actually going to then be asking if the player's x position is less than 400. Then what we want to do is set the bomb's x position to be between 4 and 800, but if the player is greater than 400, we want it to be set between 0 and 400. So we're doing this is a condensed way of writing an if-else if. So we're asking if something is true. So if the player is less than 400, we'll drop a bomb between 400 and 800. And otherwise, we will set the position to be between 0 and 400. So that means the player stands a chance when the bomb drops down on screen. So that's why we are doing that. And now we create our individual bomb, and it will be bombs create, just like we use platforms create. Set it at that X position. They'll start 16 from the top, and we'll give it an identifier of bomb with it. Now these are bouncy bombs, making them really obnoxious and hard to avoid. And then we'll third time's the charm on typing true. But now the bombs can collide with the world bounds. And then we will give them kind of a random X impetus and then a little bit of Y impetus when the bomb drops, so that they're never dropping quite the same. So we'll say negative 200, well, not 0, 0, 200, negative 200 or 200 for our X, and then our Y, they'll drop 20 on top of gravity, so they have a little push to begin with. So now when we look at that, here's the stars. Let's go start collecting some stars. So what happens is once I've eliminated all of the stars, a bomb is going to drop. We get them all, and look, there comes the bomb flying on scene. You can see it's crazy physics. Oh, look, game dead. So we've now successfully added in artwork, added in sprites, added in keyboard controls for interactivity, added in animations, physics, collisions, and even some game over logic. The next stage we'll look at is how we can then have multiple scenes and resets and other things like that.